Hi, everyone. My name is Akanksha, and I am the Content Marketing Manager here at Delta Q Technologies, part of the Zappi Group of companies. I'd like to welcome you to today's session. Please remember that the session is being recorded and will be available to watch on demand following the session. If you have any questions during the session, please add them to the Q&A tab, which you will find on the top right of your screen. Note that your questions will be sent privately. With that, I would like to introduce our speakers for today's session. I'd like to welcome Oliver Bald and Santiago Antolin from Inventus Power, who will be speaking about accelerating electrification of off-highway equipment through standardization. Welcome, Oliver and Santiago. Please take it away.
All right. Thanks, Akanksha. And thank you, everyone, to join late afternoon, evening in Europe, or in the morning on the West Coast, wherever you are. And thanks to the Zappi team to make it possible for us to attend this year's Future of Electrification, talking about how the standardization enables the acceleration of electrification for off-highway equipment, as Akanksha just mentioned. My name is Oliver Bald. I'm a senior manager for business development over here in Europe. I'm based in Hanover in Germany, and I'm working for Inventus Power now since 2020, and we'll have this presentation together with my colleague Santiago.
Hello, thank you, Oliver. My name is Santiago Antolin. I'm the field applications engineer for Inventus Power. I'm based in Spain, and I'm now in the third year working for Inventus. In total, I have more than 10 years experience in the battery industry. And at Inventus, I'm the one responsible for giving technical support to our customers in the EMEA region, creating technical specifications, and helping our customers to integrate our products into the machines and various applications.
Great. Thanks, Santiago. Let's quickly have a look on what we're going to cover today. We will just talk a little bit about Inventus Power as a company as such, and then move into what the rationale is for lithium battery pack and module standardization for off-highway equipment. And after that presentation, Santiago and myself are available for any questions. So if you have questions, put them in the chat on the Q&A section. We're happy to answer them after the presentation, or alternatively after the whole event. Okay. So as just said, real quick, an overview about Inventus Power. The basis of the company was founded more than 60 years ago, and we're still headquartered in Illinois in the United States, just outside Chicago. Our roots are in the electronics industry, from where we were starting to work with lithium batteries around 30 years ago. And when I say lithium batteries, I don't mean cells. So we are in the battery pack and module design and manufacturing industry. Our company operates around 4 manufacturing sites globally in the US, Brazil, Mexico, and China. And our 3,000 employees are working hard every day to exceed our customers' expectations and satisfaction. The manufacturing is at Inventus, which is somewhat unique, is fairly high, on a very high level of vertical integration on the manufacturing side as well as on the design side. We have even the ability to make in-house certifications in our labs, in our 3 tech centers globally. Overall, we launch around 100 projects a year, which is actually a growing number. So every year we have more and more projects for existing customers and new customers and new applications that we're working on. Talking a little bit about the transition of the company, which is basically in line with the transition of lithium batteries being in use in the marketplace for the last 30 years. So we are kind of like following the evolution of lithium battery usage in various applications. And that took the company from designing and supplying battery solutions for portable devices like consumer electronic equipment, phones, loudspeakers, or industrial equipment like handhelds and data capture equipment, towards medical applications, mobile cards, medical devices, even up to heart pumps that we're still producing today. And at the same time, we were working in the military space and are at the forefront of digitalization for soldiers, for wearable battery packs and solutions. So in line with that whole development, we were constantly increasing, well, we have seen basically a constantly increasing power demand requirement that was growing. With that is the voltage that was growing, and I think we heard it in a couple of presentations already today and yesterday, that both of this somewhat go in line. So you have an increase in power demand, and then typically you have an increase in voltage for the system as well, as you're trying to be efficient on the system usage and minimize any losses and cable thicknesses and so on. So from this legacy business in the military and medical space and consumer and industrial, we were moving forward into more of industrial equipment, traction equipment, which is classic e-mobility kind of equipment, like professional cleaning that is running on 24 volt, 36 volt, power requirements that typically are around 500 watts to 5 kilowatts. This is really a constantly changing business for us that we just started to work in around 4 or 5 years ago. And we foresee this trend in the whole market, that power is growing further and further into larger equipment, and so does voltage. So what we're trying to do is to follow the requirements in the market by providing solutions for customers that are easy to implement and are efficient for them to use in the field. Okay, so that gets me to the next. Now my slides are jumping here. Sorry. Okay, I hope we're now back on. Yeah, interesting. So that gets us to the next slide. So you have probably seen more and more electric equipment than ever before, either in your households, in your workplaces, or out on the streets, as we have a higher level of electrification on cars out there. The increasing level of market penetration of electrification, electric drivetrains, is only possible by using lithium battery systems. So the whole electric equipment is definitely not new to the off-highway market or segments. We have seen lead-acid-based systems already in the past. There have obviously been power tools on batteries, power tools on grid in the past. But a real transition now to larger systems is coming with the change of technology towards lithium, which enables larger equipment, different types of equipment, to go and follow the whole evolution to electric drivetrain. And what does it mean overall? So what we see in the marketplace today is we have two paths of technology transition. One is from a combustion engine to an electric drivetrain. And another one is from existing electric drivetrains that were using old technologies, mostly lead acid based, and transition over to a lithium based system. Right? The improvements or the advantages of those systems we've listed up in here. So ultimately, of course, from combustion engine to lithium, most of this is driven by, initially driven by legislation, right? There is a demand for zero emission vehicles in terms of CO2 emissions, or low noise level operations like overnight usage. But at the same time, there will be commercial benefits when changing over to lithium, which is you can cluster into a couple of segments. Basically, there is no maintenance required for any oils. There's less moving parts on an electric drivetrain. Overall, the emissions you don't have to care of for indoor, outdoor usage. The overall uptime is increasing because you also don't need to change oils or have longer maintenance cycles. You're pretty much more flexible overall, which obviously depends on your usage profile. When changing from lead acid to lithium, you're already working in an electric environment, but the historical requirement has always been runtime optimated, right? One discharge, one charge cycle, pretty much one per day. That was the main limitation for lead acid historically. So when changing to lithium, you have an opportunity charging that you can apply to increase your uptime versus just being runtime focused. At the same time, of course, there is less maintenance, right? No watering of any lead acid batteries. There is no maintenance cost also required for people to go there. Is a longer life, so you have less cost maintaining all the packs over life, and obviously less issues in some environments where you're operating that are not allowing any explosive gases, because you cannot charge a lead acid battery in an explosive environment, of course. So the other aspect that actually comes for both is that lithium batteries, as they typically come with a battery management system, are much more intelligent. That means you have the ability to take data from the battery packs to analyze the use profile and really be also preventive in case of things going wrong out there. So now let's have a look on the ways of how to get this done for an application. In principle, there are two ways to launch a battery system for an application, right? The question really is, what supports the business case best? And there is no easy answer to that. What we have typically seen is that in the past, pretty much all systems were more or less custom designed. So there's an application with a specific requirement, a specification for which we or anybody else would design a battery to. That comes with a project timing, of course, because you need to start ground up for every project, pretty much for a new, and it comes with a development budget in terms of cost. So what we have seen over the last couple of years since we were starting is that maybe for many applications out there and for many customers out there, the overall volume that they are targeting is not big enough to justify a full custom design, because a custom design gets more expensive the bigger the battery pack goes, which is just natural because there's a bit more NRE involved. There is a higher cost for all the samples to be built, the validation cost of all these samples, the tooling for manufacturing of a custom design needs to be included in the whole calculation. And there's going to be an agency process that need to be fulfilled, and obviously for a larger pack that's also more expensive. So what we were looking for is considering multiple applications and define a portfolio solution that is suitable for many of these segments, right? So this allows us to be quicker, or allows our customers actually to be quicker when launching a new vehicle, when transferring from an existing vehicle design that was lead acid based and gets retrofitted into a lithium system, a much quicker time to market at a much lower cost, right? So all the packs are already fully certified, so the whole integration process is quicker and saves cost. And at the same time, it gives the customers the ability to also base their future platform on existing standards. So the whole cost of getting carrying packs in the warehouse, carrying inventory, service units, everything out there is much less when you're using the same standards and apply it across multiple projects. So we see this is a big advantage, and is applicable for standard battery packs from standalone to parallel scaled units or serial scaled units, and in the same way for modules that are operating more like in a master slave environment when we talk about higher voltages, as we have seen before. So there is the two ways of what can be done, and we do both. But today we're going to talk about more of the standard sizes, as we see this a very good option actually for off-highway applications. As said, two ways to address the shifting demand out there. But of course, when we do this, we are to consider many different topics which Santiago will explain in the following slides.
Okay, thank you, Oliver. So, as you mentioned, there is more this change of paradigm in terms of power and voltages. So coming from the old times with the lead acid environment, low voltages, there is a trend to incorporate more and more lithium-ion solutions in bigger and more powerful applications, such as off-highway, light electrical, light commercial vehicles, commercial industrial vehicles. Whereas the nominal voltage of the light electrical vehicles is typically below 60 volts, eventually 80 volts, 72, 96 volts for forklifts. But we are seeing that these voltage levels are rising towards the 400 volts and beyond, even to the 800 volt range. We at Inventus, we are supporting this change. We developed low voltage solutions in standard formats, and also we developed high voltage solutions for the OEMs, ensuring not only performance but also and most importantly safety. So thanks to our experience and deep expertise shared with OEMs, we have come up with basically 4 main categories which can be the base of how to reach standardization. First is the use of standard sizes, so standard physical dimensions, modular and scalable solutions that can be adopted in different machines, different types of applications. Secondly, the compatibility. So to make the components inside in the machine compatible each other in terms of communication, cabling, software, etc. Then installation hardware, which would be supporting a good performance of the system and to create a good user experience, right? Such as displays, programming and softwaring tools, diagnostic tools, and even to be able to update the software, locally or eventually over the air. And the last category would be data analytics. So to include all means to acquire data from these devices and to be able to analyze, to track performance, for instance, duty cycles, create trends, do preventive routines. And this can be done either with a local connection or via IoT remote systems. Next slide, please. So the use of standard sizes is of a huge benefit for the OEMs and also into the aftermarket, as it gives flexibility in the installation, minimizing times, costs. A modular approach is essential into the standardization, as it will help OEMs in case of different profiles, different types of enclosures, etc. By adding one or more modules into the machine. As you can see in the pictures, the models, the ones that we have for the low voltage environment, can be mounted up or on the side, so making the whole installation much easier, much efficient. The models can be even hand carried by one person, thanks to an ergonomic design. So yeah, basically it helps on the overall serviceability, and in case of replacement, it's much easier. Next slide, please. So when it comes to the design and development of a battery pack, Inventus takes into account the application type, functionality, performance, safety, and quality, and starting by determining the right cell selection. We need to consider different aspects of the application, such as power versus energy, what the temperature is going to be, the load profiles. So understanding correctly the environment which the battery will work is crucial to determine the cell. As you can see here on this spider graph, nickel, cobalt, manganese, aluminum cells, which has the highest specific energy, will be used in applications which will need high amount of energy in a small reduced space. LFP, iron phosphate, with higher power, longer life, will be used in applications which need long life and high rates. Lithium titanate oxide, LTO, will be used in applications with the need of high power and especially fast charge power. The cell technology has been evolving, obviously, into a more efficient, more energy, power, and a longer life, with the addition of new sizes, cylindrical 21700, 4860, and also bigger prismatic cells. Next slide, please. Once the cell has been determined, then the design of the BMS, battery management system, comes into place. The BMS has to be designed around the cell specifications with the protections limit marked by the cell manufacturer, and accordingly to the application, voltage and power. Thanks to the numerous sensors inside the battery pack between cells, BMS, it can monitor and manage the cell charge, cell discharge, voltages, currents, and temperatures. BMS can disable or enable the heater, trigger faults. It will calculate the state of charge, the state of health. So it's really the brain of the battery pack. It can be built in of the battery pack, or it could be also external, thanks to the communications. The BMS communicates with the exterior devices in different protocols, which mostly used in this type of industries are the CANopen Gen1939. And yeah, for diagnostic purposes and for data exchange between the charger and the BCU, also it's important to have standard communication protocols. It shall be configurable in the field, upgradable either locally or via over the air. And of course, it shall comply with the functional safety regulations, such as the ISO 26262 for on-road vehicles. Next slide, please. So in terms of integration, we have clustered the integration levels into three main levels or categories. One would be the basic integration, which would be like a lead acid battery integration. So there is no communication, there's no intelligence, there's no communication between the vehicle control unit, charger, and battery. That's the most simpler integration. Then we go into the semi-integration, where we have basically the BMS of the battery and the charger in closed-loop communication. So exchanging data and doing what we call smart charge for a better charge process. And then we got the full integration, which is the most intelligent, where all devices are in communication, sharing instantaneous values, data. For example, motor controller is receiving from the BMS the maximum discharge current available at certain moment, depending on the temperature, state of health, state of charge, as well as doing smart charge as well. There are different charging options available in the market. Either could be wired or wireless, onboard, offboard. And we are seeing more and more, especially when it comes into the high voltage, these DC fast chargers coming into the market. Next slide, please. As mentioned, the BMS is the brain of the battery system, but it could also be the brain of the complete machine, depending on the level of integration and also the OEM requirements. For a full software integration, is key to maximize the performance of the machine. The interconnected systems provide real-time information, helping determine the performance of the machine, and with data analysis and machine learning, this performance can be optimized, minimizing downtimes and making preventive decisions to help minimizing operational and maintenance costs. The algorithms can run inside the vehicle control unit, and with IoT can be sent for remote visualization or locally with smart monitors. Concern might be into the data security and hacking, and we as manufacturers need to design robust architectures to minimize this kind of risk. Next slide, please. In terms of regulatory, there are norms which specify the use of lithium-ion batteries depending on the application and type of machine or vehicle. Here you can see for the US mainly the UL 2271 and UL 2580. These are the main standards. And in Europe, the IC 62619 and the EN 1175 for material handling, which includes the lithium-ion batteries as well. Batteries has to go through various tests, and as you can see here in the pictures, there are some tests that Inventus Power does in-house, as we are accredited lab for UL and TUV. The must-have is the 38.3, the UN 38.3 for transportation, shock and vibration, ingress protection, crash, nail penetration, immersion. These are all must. And we also do the ECE R100 tests, and this test is for road homologated vehicles. It's very strict tests, and with one of the most important, which is the external fire test, which the battery needs to withstand an external fire for around 2 minutes, among other tests like shock and vibration, external short circuit, etc. Next slide, please. Coming towards the end of the presentation, we would like now to focus on the transportation and battery storage. There are in place standards specifying the transportation rules depending on the transport mode. By air from IATA, road, for instance, here in Europe, based on the ADR, and sea freight based on the IMO, and the UN allocated numbers to the lithium batteries, if these are shipped alone or shipped inside containing equipment, different UN numbers, but the classification is classification 9, class 9, as this mark is, this sign is marked here. And when it comes into storage, basically the rules to apply should be the ones followed by the local regulations, and also followed by the manufacturer recommendations. For example, basic recommendations, to store batteries between low state of charge to minimize energy content, check the battery's state of charge once every year, charge batteries when the SOC falls below 10%, and in any case, charge the batteries at least once every 2 years during storage.
And yeah, maybe adding to that, one of the things that we're also focusing on at Inventus is obviously to get the BMS in a ship or transportation mode for a low consumption, so we minimize the consumption in storage and during transportation. And we always go for a IATA approved packaging that we go and certify against, so we have the ability to service our customers all around the world in case of emergency by plane. Okay, thanks, Santiago.
Okay.
So yeah, just wrapping things up here a little bit, as Santiago mentioned, what are the important things to consider? And obviously, this is not an exclusive list. There's many things to consider, in particular for every application. But the important piece for us is that we consider the cell selection when we look at a standard battery pack or a module for a particular market segment. We check on the mechanical fitment, that we have the ability to cover as many different applications in the market as possible, and unify our BMS communication structure so that we enable to use the same hardware that is detached or attached to the batteries for multiple different modules and packs. Same to the software structure as such, which eases up the system integration for our customers a lot. And as I said, there is many regulatory requirements out there by country. We try to cover the most relevant ones in the core regions. It may not always be 100% coverage because there is regional requirements, but the key important thing for us is that mostly everything links to the main global standards that we are fulfilling with our battery packs. So that's the key takeaway, I think, from today's meeting as such. So with that, as said, we're here now to answer any questions you may have, anything that came up along the presentation. We can post in either today, or feel free to reach out to us at any time after the whole ZAPI session. Right.
Perfect. Thank you so much, Oliver and Santiago. We do have a few questions. So one of the questions we have is, what is the typical integration process you follow at Inventus?
Hey, Akanksha, I couldn't really hear you. I don't know if it's...
Yeah, there's some background noise.
Yeah.
Oh, sorry. Can you hear me now?
Oh, there is some interference, it seems.
I think the question is about the integration.
You mean like an integration process? Now we've lost you completely.
I think the question was about the integration. So how we do the integration of the probably how to do the integration of the battery packs into the systems.
A customer system.
So
yeah,
basically what
hear me now? I apologize.
Yeah,
now yes.
Yeah, so what is a typical integration process you follow at Inventus? That was the question.
Okay.
Yeah. So basically what we follow is to, we follow the process, but basically the first thing to do is to understand the customer application and requirements, right? This is really crucial, important. Understanding the powertrain specifications, inverter, charger, and based on the requirements, then we can basically check whether we can incorporate a standard pack that we have in our portfolio, or basically to do a custom pack, right? So based
exactly.
on
And that is like the first level of analysis. What is the best solution for the customer, and also what supports the customer business case best, of course. And then in terms of really getting into the details of an integration, we will have a couple of joint calls typically with the customer to analyze more details on the integration process, like CAN connection, integration level in the vehicle, down to coming on site and setting up prototype vehicles with the customer to ensure everything works fine and as expected.
All right, so the next question that we have is, why is ECE testing important for off-highway equipment?
Well, basically the ECE R100 is important for, let's say, road homologated vehicles. Basically, it's so the regulation basically provides confidence to the OEMs, ensures they are using safe batteries under all driving conditions, and especially under the most particular and important scenario, which is the crash. So the battery needs to go into different tests. As I said, for instance, this external fire, but also thermal and mechanical shock, intensive vibration, and it needs to withstand all these tests so that it's safe to be used in road vehicles, right?
Right, exactly, and we really see more and more vehicles that might originally have been designed for an off-road or an industrial utilization that are now moving more towards smaller delivery vehicles out on the road. So it also helps converting the existing vehicle designs to be street homologated. And obviously, when you're using components that are already passing or have had that certification, it's much easier to integrate and change over for this different market segment for the customers.
Perfect. So what are the major obstacles for the integration process?
Okay, so basically, I mean, I think from my opinion, one of the major obstacles in the integration process is to reach this what we were discussing before, the full integration. So to make the the BMS from for instance from Inventus talking to a charger and talking at the same time to the to an inverter, sharing information so that the inverter can understand the data that is coming from the BMS charger as well. So the full integration, because of at the moment not so uniform in terms of communication protocols. This is something that I'm seeing as an obstacle, but it's actually improving, so that more standards are put into place now, thanks to the CAN Open, for example, that it's a common standard, common language. This is much easier. But yeah, I mean, the one of the major obstacles is to make the coming from a lead acid environment where there was no communication towards a full integration where all components are in communication. This is quite tricky, I have to say.
Yeah, it's tricky. It requires the expertise on the customer side, which obviously we are supporting them with as well. But in particular, when transferring an existing design that was built or designed for a lead acid battery usage, it is also about understanding all your requirements, because lead acid battery as a if you will, stupid battery is always taking everything you give them and always provides power until it's basically collapsing. So there might be some short peaks from a controller or from any other system that just come in very, very short. And typically your lead acid battery has filtered this out for many, many years in the market. As lithium batteries have a high sophisticated BMS and electronics on board, we need to safeguard the electronics. So we need to understand and analyze if there are any peaks. And even if we experience this, sorry, in the marketplace, and customers do not necessarily have the expertise to understand what is out there, we are coming by. And I mean, I have seen Santiago traveling around with an oscillograph to figure out what is the microseconds peak that we see that potentially makes the BMS trip.
Yeah, of course. I mean, another point is, once you have the machine ready, and of course, before launching the machine into the market, it needs to have various iterations, and the various iterations comes with do a lot of field testing, right? So various conditions, various types of movements. For instance, a boom that can be going up and translation at the same time. So this kind of movements, it's very important to do field testing and to understand all kinds of requirements that can come from the real customers in the real field, right?
All right, and another question that we have is, what is Inventus Power's cell chemistry preference and why?
Yeah, an interesting question. We do not really have a preference. And as we mentioned before in the presentation, we are as such cell agnostic. We are not involved in cell manufacturing ourselves. So we are somewhat agnostic to the technology. So what we do is we pick the right choice for the project. For our standard products, of course, we need to make a choice. And we take this based on what we see as the target market for that particular design. If it comes down to a custom project, we need to understand the requirements to make the best choice or even offer various options to our customers. Very often, we actually qualify 2 different cell types or manufacturers for the same project to ensure security of supply.
Perfect. So those are all the questions that we have for now. Is there any closing remarks that you guys have? Before we end?
I see actually Murad posting a question on the chat here. Maybe read this out. What type of voltages or ripple levels are acceptable by the batteries?
Yeah, so if you guys want to answer that.
Yeah, so it ultimately depends on what type of battery we are talking about. Obviously, the batteries, every standard battery has a certain voltage, and most or many of the packs are only to be connected in parallel. So that limits the overall voltage already. As such, for the charger to, which I assume Murad's question is leading to, for the charger to operate in. And then on the ripple level, Santi, I don't know, you want to add some?
No, I think it's fine. So the maximum voltage will be accordingly to the to the BMS and cell specifications. It can support some ripples, but typically the charger will filter this towards the battery. So we should not be quite concerned on this.
Perfect. If anyone else has any other questions, we have about 15 minutes left. So we'll give you about a minute or 2 to submit any questions. Otherwise, we will wrap up and end the session.
Okay.
So I don't see any other questions. That is all that we have for today. Thank you so much for speaking, Oliver and Santiago, and thank you everyone for attending the session. You can now head to the lobby to attend the next sessions on the schedule. Thank you, everyone.
Thank you, everyone. Thanks,
Thank you, everyone. Thank you. Thank you, Akanksha. Bye-bye.
Bye.